Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this very interesting problem of GFG. So let's move on to the problem. The problem is merge two sorted linked list. Okay guys. So guys, here we are given two values n and m. Okay, and we are given a linked list and a second linked list, and we have to merge them in sorted order. Okay, these given linked lists are sorted already, and we have to return a finally linked list. Okay, so means we are given two linked lists, we have to sort them. Okay, so guys, how we will do it? There are many ways to do it. Like you can store all the, like, these are the given linked list, you can store them in vector, then sort the vector, and then make a new linked list. Okay, and return the front node. This is also one way. Okay, but this is not so much efficient, because I think you have to do in oven, approach. Okay, so guys, how we will do it? So is what I am doing. This is linked list first. This is head one, means node of first linked list. This is head two. So we are taken two nodes on we are taken two nodes. I just take the name answer and cur. Okay, I am taken two node, that is answer and cur, and both I initialize at null. Null. Okay, both are null initially. So what I am doing, guys, if what I'm doing now, if my 5 from my 5 and 2, I am comparing my 5 and 2. Okay, I am comparing my 5 and 2. Now h is minimum, 2 is minimum, so my first node should be 2. Okay, so I am checking if my answer is null, means this is my current node, so I have to update my answer as well. So how I am doing this, you can see now. Current is okay. So how I am doing this? So this is the node, I just change the color to red. So this is to red node. Now this is my current node as well, and now this h1 h2 I moves to h2 next, means next of it. Now h1 remains here. Now we compare this 5 and this 3. Now 3 is minimum. 3 is minimum. So I will again check if my answer is null. No, now it is not null, it point to some node. So what I do in the current node, in the next of current node, I just put 3. And I move h2 to next of h2, and move current to next of current. Answer is my head node and current is my current node, in whose next I have to add the new node. Okay, so this is my current node, this is my h2, this is my h1. H1 is constant till now. So now I am comparing 5 with the 20. Now 5 is minimum. So now in my current next, I will add 5. I will add 5. I just putting the address. So this is O1. I am not making a new node. I just putting in my next the address of his node, and move my h1 to h1 next, because this time I am doing approach on h1. So I just move h1. That's why I will do h2, and again I will move my current node already as well. This is my current node. Okay. So now my h1 is this, h2 is this. Compare again. 10 is minimum. So in current next, I just make out 10. Move out h1 to h1 next, move out uh, current, sorry. Okay, now compare 15 and 20. Now 15 is minimum, so add 15. Move my current and move my h1 to h1 next. Now h1 is this, this is null. At last it will point to null. This will point to null. This is O n plus m approach. N is the size of this linked list, m is the size of this linked list, m, and n and m are number of nodes in particular linked list 1 and 2. Now we are compare 40 and 20. Now 40 and 20 is minimum, so I just add 20 in the linked list. Now my h2 is point to null. I just change the color again so that it is more clear. Now my h2 is point to null. Now my current will point to 20 now, because so you can see my answer remain constant. It is the front node that I need to return, head node of my answer linked list, my merge linked list. This is my current node in which I will do the operations. Now my h2 is null, and suppose if there are some 500 nodes left, if this is null and these all nodes are in sorted order, so we know all the nodes after 40 is greater than 40, so this linked list is sorted order. So I can do in the next of this, I just put address of this. So this is 40 now, this is 40 now, and how many nodes it will contain, because in one linked list I just point to null, I just reach null in one linked list. So I will put the next linked list head in this, and I will not move head, but I will call a break statement. Why? Because now I reach the end of one linked list, so all the nodes of my second linked list already come in the next position. Okay, I don't move per, I don't move as, I just call break statement. Okay, I am giving you one more example. I am giving you one more example. Okay, I hope you all understand this. This is a very simple approach that I told you. Now, here comes one more example. Suppose this is H1 contain 1, then 2, then 3, then 3. Minimum number of nodes is 1. Okay. Now this is my H2. Suppose this is 0. So initially I compare this 1 and 0. So my answer and all are null. So answer will point to 0. Answer with current is this. Now this will point to null. This will point to null now. This is my node. This is my this node. So suppose if this is similarly go, see this similarly go to 10 raised to the power 5. So total number of nodes here is 10 raised to the power 5, and it contain only one node. So it does not have any benefit to compare null with any value, null with any value. What I can do, I just put one here, and all the remaining link list come here, like 2 till 10 raised to the power 5 at now. So all nodes come here, and this linked list remaining sorted over. So in open time for these all linked lists left, if once I reach the null of any linked list, means the end of any linked list, I just put the complete linked list remains. I don't move car, I don't move h1, I just call break. I just call break now, because one linked list I iterate completely, second linked list I put on next. So I am automatically come the end of the linked list. Okay, so both linked list I traverse completely, I just return answer. So in this case also I just return answer is my head node. Okay, so you can see I am taken, this is given to me node head 1 and head 2. I just return, I need to return the head of the my sorted linked list, merge sorted linked list. So I am taken two variable, answer is the head node and current node, in which I have to do operation initialize both with null till my head 1 or head 2, means there is one linked list which is not null, means which is not end yet. What I will do, I will explain um, these two after. Okay, after these two, first of all I want to tell you this. Now, if the data of my head 1 node is less than or is equal to my head 2 data, then what I will do, if my answer is null, means this is the first node, I will initialize my answer and current as to head 1 and move head 1 one step. Else while I will put in current next, in next of current, in next of current, this is current and this is next of current, I just put 5 4, like I just push head 1 current node, move h1 a little bit. Now head 1 and head 2 are not the head. This is the temporary node, you can say, like head 1, like head 1 move from here, 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 here again. Okay, I had to move one by one step. Okay, so I will move one step head 1 now and move current as well. Okay, and if my head 1 is greater is not less than or is equal to head 2 data, means our head 2 data is less than head 1 data, then means I have to add head 2 data. So if my answer is null, then I will initialize answer and current head to move head to one step. Else while if my answer is set already, it contain a node, it is not null. In my current next, I will put head to the current node, uh, and move head to one step, move current one step. Okay, but if my head to is null, means I have completely. So according to my while condition, there is at least one linked list, whether it is head to or whether it is head one, that is not reverse completely yet. Why? Because I am writing or here. Or means either my head 1 is not is equal to null, or my head 2 is not is equal to null. So if my this condition satisfy, means my head 2 is equal to null. Not head 2 means not head 2 means this is not head 1. This is not head 1, means if this is null taken as 0 and this is 0, this is not, so not 0 will makes me 1. So 1, if 1 means true. So if my head 1 is null, means my head 2 is the remaining linked list. My head 2 is the remaining linked list. And suppose if my answer is not initialized yet, okay, according to this we have at least one node, but sometimes GFG constraint are not that much effective or accurate. So I just, for to be safe side, I make, if my answer is not initialized yet, I just initialize my answer with head 2, means head 2 linked list is my answer now, and I just call break. Elsewhere my answer is initialized already, it contains some node. In current text I will put head 2 and call break statement. Similarly, if my head 2 is equal to null, in my, if my answer is not in initialize initialize uh, okay, if my answer is not initialized, I will put head 1 in my answer. Else while in next of current I will put head 2. Okay, if my head 1 is null, mm, if my head 1 is null, I put this linked list. If my head 2 is null, I will put this linked list. Okay, if head 1 null, then head 2. If head 1 null means I have left with h2, or if h2 is null, then means I am left with h1. Okay, so and here I am comparing, then at last I just return answer that contain my head node. So I am trying to run it. You can see correct output it is given, it is shown to me. So you can see all the 303 cases, test cases pass out. I am taken is also linear. So I hope you all understand this. If you still have any doubt, then just comment out. I will try my best to explain you. Meanwhile, you can subscribe the channel, like the video, and if you understand the approach and like the content, then please comment out, as it will motivate me to make more this kind of content. So please subscribe, like, and share the video. Thank you for watching this, guys. Stay tuned.